Hi guys, good morning. Today we're going to be taking a look at the Unit 11 packet. Notice that for this particular unit there's not a separate classwork and homework packet. We're going to be doing some examples from there and the remainder will actually be assigned as your homework, alright? So for this unit we have a unified packet, alright? Now, in terms of what you need to know to be successful with 2D area and 3D volume, page 1 gives you a list of formulas, okay, for plane figures, which is a fancy way of saying flat figures. It's actually a little bit more than you need to know. All you guys need to know are the following. For a parallelogram, which means any rectangle, any rhombus, any square, any parallelogram, your area is simply defined as base times height. For a triangle, your area is defined as 1/2 base times height. For a circle, right, your area will be defined as pi r squared. And last but not least, for a trapezoid, I'm just going to draw a little trapezoid here, it's defined as 1/2 times the height times the sum of the bases, okay? So, these formulas are nothing new. We've actually been working with them pretty much since the middle of quarter 1, right? We've looked at them more in the coordinate plane than just kind of like sitting randomly in space, but you guys have seen all of these before. They should not come as a surprise. You've also seen them in 7th grade and in 8th grade, so even though there may have been some time where you haven't been asked to use them too much, we are not looking at new content here. Now, what do you actually need to be able to know and do with these formulas? Well, you need to be able to find the area of what are called composite figures. So let's take a look together at page 2. Now, composite figures it's a fancy way of saying, well, when you combine two different shapes together and you want to find an area, you got to add up the different pieces, okay? So let's take a look at some that upon first glance might look really, really weird, but upon closer inspection are actually not too bad at all. The one we're going to take a look at first is question number 2. Once again, which number? We're going to start with question number 2. Now, number 2, I got to be honest with you. When I first saw this, I was like, what the heck are they thinking, right? Because it looks super, super weird until you realize what they've drawn. Okay, first things first. Why do you guys think that they put these little arrows here? What shape did they want us to what shape did they want to clue us in that we had? Well, arrows mean parallel, right? So what I've got here is a parallelogram. Okay, so the parallelogram is there in the middle, right? And on either side of it, what shapes do I have? Well, I have two semicircles, which when you put them together, what do they make? A whole circle. So, I can visualize this figure as being essentially a circle, right? Because two semicircles make a circle and a parallelogram. So I can say that the area is going to be pi r squared plus bh. And if you're wondering where I got those formulas from, please refer to the top of page 1. Okay, so far so good. So now let's plug in some numbers. They give me the radius, right? And so I would say that the radius here is 6. So I'm going to plug in 6 for r. And then my base, well, let's think. If the radius is 6 and I need the whole thing across, well, that would just be the diameter, right? Which is going to be 12. And what's the height? They give me that right here, which is 5. So if you do the math, you end up getting 36 pi plus 60. And I'm going to get my handy-dandy calculator over here, and let's do some math. So I've got 36 times, hit the pi key, so that's 113 point something plus 60. All right, so my final answer here should be around 173, I'm just going to rewrite that, 173.1. All right, so in the computer, if they ask you to round to the nearest tenth, that would be what you round to. All right, the next one we're going to look at is question 4. If you're wondering why I'm skipping around, well, it's because the other ones are going to be your homework problems, all right? But I want you guys to just get a feel for the method here. Identify the shapes that make up the big one, split it up into the smaller shapes, find the area of each one, all right? So, question 4 looks a little bit like an ice cream cone, doesn't it? Look at that. It's a triangle, and it's a semicircle. Hooray! All right, so 16, 17, 17. Now, a couple things here. First of all, I actually know what two shapes I'm looking at, right? I'm looking at a triangle and a semicircle. So that means my total area is going to be, well, a triangle is 1/2 base times height, so I'll write that down. And a semicircle, well, a circle's pi r squared, and so what fraction of a circle is a semicircle? 1/2. All right? So, let's talk about some numbers. I know the base of the triangle, I don't know the height, right? So I'm just going to draw the height here. Oh my god. If this is 16, what's each piece? This is going to be 8, because it's a radius, right? Oh my gosh, what theorem am I going to have to do? Yes, my favorite theorem ever, the Pythagorean Theorem. So I'm going to say 8 squared plus b squared equals 17 squared. 64 plus b squared equals 289. Subtract 64 from both sides, and I get 225 equals b squared, and b equals 15. Right? So, when I say b, by the way, I'm not talking about base. I'm actually talking about the height. Alright? I apologize if there's any confusion there. Alright, so now we're ready to find the area of that triangle, which is 1/2 of 16 times 15. And then I'm going to be adding, right, 1/2 pi times 8 squared. So let's go do some math. All right, so 16 times 15, All right, so this is 120 plus 8 times 8 is 64. That's 32 pi. So let's do some math here. 32 times pi equals plus 120, and I would get around 220.5 as my final answer. 220.5. So once again, what was my method here? My method was big shape, that's the composite shape, split it up into its smaller components, in this case a triangle and a semicircle, write down the area formulas for each one, find their separate areas, and simply add them together. Alright? In the next video, we're going to take a look instead of adding them together when we have cases where I have pieces missing from a shape. Alright? And I instead have to subtract them.